Hi friends, myself D.K. Narale, working as an assistant professor in Gopal Krishna Gokhale College, Kolhapur. Today we will discuss B.Sc-II semester 4 chemistry paper 7 inorganic chemistry. Today we'll discuss about the coordination chemistry. Coordination chemistry means which deals with study of coordination compounds called as a coordination chemistry. Outline of this topic: introduction, definition and formation of coordinate covalent bond in BF3 NH3, ammonium ion, water molecule. Second point, distinguish between double salt and complex salt. In second, Werner theory, the postulate of Werner theory, the theory applied to cobaltamine, 4 molecule of cobalt amine chloride molecules. Description of the terms ligand, coordination number, coordination pair, effective atomic number. IUPAC nomenclature of coordination compound. Isomerism in complexes with coordination number 4 and coordination number 6. Geometrical isomerism, optical isomerism. The structural isomerism, it contains first ionization isomerism, second hydrate isomerism, coordination isomerism, fourth linkage isomerism, and fifth coordination position isomerism. And last point in this topic, valence bond theory of transition metal complexes with respect to coordination number 4 complexes like Cu and Ni, and second, coordination number 6 complexes of iron and cobalt. Before starting the important terms in the introduction, definition of some important terms pertaining to coordination compounds. First, coordination compound or entity. A coordination constitute a central metal atom or ion bonded to fixed number of ion or molecule. That is called as a coordination compound. Next, central atom or ion in coordination entity, the atom ion to which fixed number of ion or group bound in a definite geometrical arrangement between these geometrical arrangement around it is called as a central atom or ion. This central atom or ion. Coordination number, the coordination number means the number of atom or ion directly linked to central metal atom. That is, the number of atom or ion molecule means the ligands directly linked to the central metal atom in is called as a coordination number. That is, metal ion in complex can be defined as the number of ligand donor atom, that is this to which the central metal is directly bonded. This, according to this example, coordination number is 6. That is, 6 ligands are directly attached to central metal atom Fe. That is, coordination number is 6. In last terms, coordination pair, this central atom or ion and the ligand attached to are enclosed in square bracket. That is, this square bracket and is collectively termed as the coordination pair. These ionizable group are written outside the bracket and are called as a counter ion. Very important, coordinate bond. A bond formed when 2 electrons required for sharing between 2 atoms are contributed by only one atom only. That is, it is a coordinate bond is denoted by this arrow. This side is donor, this side point of the arrow is the acceptor. Example, ammonium ion, hydronium ion, NH3BF3. Condition for the formation of coordinate bond. Very important, these three conditions. One of the absent, then the coordinate bond is not formed. First, donor atom. That is, donor atom means should have at least one lone pair of electron. Donor atom contain at least one lone pair of electron. But in second condition, acceptor atom must have at least one empty orbital in the valence shell. At least one empty orbital in the valence shell. Third point, these two combination atomic orbital of donor species containing lone pair of electrons should be able to overlap with the empty orbital of the acceptor species. Examples of the coordinate covalent bond. First, ammonium ion. The lone pair of the ammonia is on nitrogen. These lone pair donate to empty orbital of H plus ion to acceptor to form a coordinate covalent bond between ammonia and this H. In second, water molecule. This water molecule with empty orbital of S orbital of the H plus hydrogen ion. This lone pair on oxygen donate to the hydrogen ion to form a hydronium ion, form the coordinate bond between H plus this H2O and H plus. And last example, the mainly coordinate bond formed by Lewis base and Lewis acid. In Lewis acid act as a acceptor species, and Lewis base act as a donor species. In this example, the amine ion is the Lewis base. This lone pair on nitrogen donate by the Lewis acid, that is B is the acceptor BF3. The B atom has an unfilled valence shell. These bond form and the dissociation at the room temperature to form these adductor, that is Lewis acid Lewis base complex. New coordinate bond is formed. Distinguish between the double salt and complex salt. Double salt means the molecular compounds which exist only in crystalline state, but in lose their identity in solution. That is, there is lose their identity by the salt, simple salts. But in complex salt, molecular compound containing at least one complex ion is called as a complex salt. Second difference between the double salt and complex salt is its solution gives positive taste for the constituent. In solution state, these are the all these mixed salts in water to this shows the positive taste for various constituent in the solution. But in complex ion, its solution does not give positive taste for all the constituent ion because the one of complex is formed. Nature of bond is ionic weak van der Waals forces in the double salts, but in complex salt nature of bonding is ionic covalent and coordinate covalent bond. Fourth difference is complex ion is absent, complex ion is present. Fifth difference is it is the association of two or more simple salt in crystalline state, but it is the mixing of two or more simple salt to form a complex salt. Example, these two or more salt, potassium sulfate, aluminum sulfate in water to form a double salt. In this example, 4KCN plus FeCN2 gives K4 FeCN6 complex. Again example, more salts and potassium, and these potassium hexacyanoferrate, hexaamine cobalt 3 chloride. Most important Werner's theory of coordination compounds and its postulate. Werner in 1893 produced his theory of coordination compounds. The main postulates of the coordination compound is very important. First postulate is, in coordination compound metal shows two type of linkage. Two type of linkage means valency, that is two types of valencies, primary valency and secondary valency. The primary valency are normally ionizable and are satisfied by only negative ions. In the complex, the primary valency ions are shows only negative ions. Third postulate, the secondary valencies are non-ionizable. In square bracket, there is no ionizable, close square bracket. These are satisfied by neutral molecule, negative ion or positive. All these ions are shown by the secondary valency. These are the shows in the square bracket. Fourth postulate, every metal possesses fixed number of secondary valency called as a coordination number. Example, secondary valency is 6, then the geometry or its stereoisomerism or its birth of stereoisomerism is 6 coordination compound is octahedral geometry shows octahedral 4 coordination, 2 type of geometry, square planar or tetrahedral. Fifth postulate, secondary valency are directed towards fixed position in the space, that is the stereoisomerism. The last postulate, the combining power of metal is individual into two sphere of attraction. In two sphere, one is the ionization sphere and one of these coordination sphere. Inner sphere, that is closed square bracket, called as a coordination sphere, or outer sphere, that is ionization sphere. These are 6 Werner's postulate, very important for the coordination compound or complex. Applications of the Werner's theory. In this example or in this picture, orbital picture, these are the two sphere. One of these inner sphere is called as a coordination sphere. Inner sphere is called as a coordination sphere, and the outer sphere is called as a ionization sphere. In this example, for example, first example, molecular formula of the compound, coordination number, Werner's structure, and information about the formation of complexes. First example, COCl3 in 6NH3. Coordination number is 6, that is 6 are the inner sphere are the ammonia, that is 6 ammonia and 3 chlorine ions. In this Werner structure, octahedral structure, the ligand NH3 satisfy only secondary valency. 6 ammonia molecules in the inner sphere, that is coordination sphere, this shows the secondary valency only, and remaining 3 Cl are the dotted line. These are the ionizable ions with primary valency, Cp as denoted. In second example, 5 ammonia is only shows the neutral ion are the inner sphere, not outer sphere. Positive or neutral ions are not coordinations, out of coordination, only shows the coordination sphere. In this example, 5 ammonia molecule shows in the coordination sphere secondary valency, and one of the chlorine, that is these indicated by dotted line and wedge line, are the secondary valency. In once Cl minus satisfies secondary valency as well as primary valency, the remaining secondary valency are satisfied by ammonia molecule. In this, two chlorine molecule shows the primary valencies. In this example, third example, COCl3 4NH3, coordination number is 6. Again, 2 Cl ion shows coordination pair and 4 amine molecule shows again coordination pair, and remaining 1 Cl molecule is primary valency, non ionizable. These two are the shows. This wedged line and dotted line CLR shows secondary valency. All these are the shows the secondary valency, and one remaining one shows the primary valency. 2 Cl ion and 4 NH3 molecule satisfies secondary valency. And last example, in this COCl3 3NH3 3NH3 molecule shows the secondary valency. Again 3 Cl molecule again shows the secondary valency. Cl ion shows secondary. In this, all these examples as per circle diagrams, outer sphere or ionization sphere, these outer sphere, these ionizable sphere, and inner sphere is the coordination sphere or inner sphere. The 3 Cl shows the ionizable sphere, these 2 shows ionizable sphere, and these 1 shows ionizable sphere, and in this molecule there is no ionizable molecule. These are not conductive molecule, these are 3 are conductive. This studied by potentiometric and conductometric study. This structure molecular formula of these four molecules according to this circle diagram. First CO NH3 6 in square bracket as per the ionization sphere, and remaining in closed square bracket, and these Cl3 are the out of coordination sphere or ionization sphere as per the remaining 3. Limitation of Werner's theory. This theory does not explain or correlate electronic composition of the central metal with the formation of complexes. It is incapable of explaining magnetic properties of complexes. The magnetic properties pair unpair the electronic composition of central metal in the Werner theory does not explain by the magnetic properties of complexes. It does not explain DD transition in the color and spectra of the complexes. DD transition means one of the electron one d orbital to another d orbital excitation. This theory does not explain. It failed to explain why four coordinated complexes are either square planar or tetrahedral. This depends on the majorly nature of ligand, low spin or high spin complexes. The Werner's theory does not explain by these four coordinated complexes. It also failed to explain why same metal shows different secondary valency with different ligands. This theory, example 3 coordination, 4 coordinate number, 5 coordinate number, and 6 coordination number. These are the postulate of the Werner's theory. Difference between primary valency and secondary valency. The primary valency of metal ion positive in most of the cases and 0 in certain. Primary valency shows the oxidation state of metal only. The secondary valency as the coordination number in closed square bracket shows the secondary valency of the metal. Shows before slide you discussed about the secondary valency and primary valency. The primary valency is always satisfied by only negative ion. Only negative ion shows the primary valency, but in secondary valency is satisfied by a negative ion, neutral molecule or positive ion. Third difference in primary valency, the primary valency are non-directional, but in the secondary valency are the directional. Example, in COCl3 6NH3 the primary valency of cobalt is +3. This shows by Cl3 minus ion. In COCl3 6NH3 the secondary valency of cobalt is shown by 6NH3 amine molecule. Terms, descriptive terms in the complex or coordination compound. The ligand, first the ion or molecule, those are linked directly with the central metal atom or ion in coordination compound or coordination complex called as a ligand. Classification on the basis, classification of ligands, first is on the basis of charge. In ligand, nature of ligand is negative ligand, positive ligands and neutral ligands. Negative ligand Cn minus F, F minus Cl, NO2 minus, and positive ligands example NO2 plus, NO plus, hydrazine ion 3 plus. Neutral ligands water molecule, amine, carbonyl, ethylene amine. On the basis of number of donor sites, monodentate, in this, if ligand has only one point of attachment with the central metal atom in complexes called as a monodentate ligand. That is, in this example water molecule only one donor atom, that is O, and in amine molecule only one donor atom is N. Bidentate ligand, the donor atom site, if the ligand has point of attachment is more 2, in bidentate ligand, if ligand has a point of attachment is 2, then the in point of attachment 2 with central metal atom in complexes called as a bidentate ligand. In this example oxalato, that is oxalic acid 2O minus donate the lone pair to directly central metal atom. In amine, ethylene diamine, these two N donate the electron directly to the central metal atom. In polydentate, if ligand has more than one point of attachment with central metal atom in complex called as a polydentate ligand. Example EDTA, ethylene diamine tetraacetate hexadentate ligand. On the basis of bonding, chelating ligand means that is the ring formation compound. A bidentate or polydentate ligand which forms more than one coordinate bond in such a way that a ring is formed. By that is central metal atom more than one coordinate bond formed with the central metal atom called chelating, that is a ring formation compound. In bidentate ligand, these two nitrogen atom donate to central metal atom to form a 5 coordinated ring, 5-membered ring formed, and that is the stable. Another is the ambidentate ligand. Ambidentate ligand, monodentate ligand which contain more than one coordinate atom or donor atom. That is, in this nitro group, nitrogen also donor atom, oxygen also donor atom. That's called as a ambidentate ligand. Ligand must two donor atom in single ligand, that is called as a ambidentate ligand. In this nitro group, oxygen is donor to central atom, electron donate to central atom, that is called as a nitrito, but in nitrogen is donate to central metal atom, called as nitro. In Again I saw thiocyanato and cyano. In polydentate ligand, type of ligand, name, abbreviation and donor atom. Monodentate, water and ammonia, aqua. In abbreviation, aqua and amine. This only one point of attachment by oxygen is donor atom. In this amine, nitrogen is donor atom. In bidentate ligand, ethylene diamine. In ethylene diamine is indicated by these two arrow by nitrogen. That is bidentate ligand. Oxalato, that is oxalic acid. In IUPAC nomenclature by coordination compound, oxalato, abbreviation is OX. Then these two oxygen are donor atom. Dimethyl glyoxymato, DMG, these two nitrogen atoms are donor. Tridentate, diethylene tetramine, diene, that is 3 nitrogen are the donor atom. That's why called as a tridentate. Dentate means teeth. Tetradentate, triethylene tetramine. Triene is abbreviation. 4 donor atoms, that's called as a tetradentate. Hexadentate, ethylene diamine tetraacetato. EDTA is short abbreviation. In this shows 6 donor atom, 4 oxygen atom and 2 nitrogen atom. Second terms, coordination compound. In coordination compound, second term, coordination number. The number of ligand donor atom that surround central metal ion or atom called as a coordination number. The number of ligand are directly linked to central metal atom are called as a coordination number. The example, coordination number 2, it's contain 2 ligand are here in this complex, 2 ligands. That's why coordination number is 2. Then 2. Coordination number is 3. Number of ligand count is 3. That is I3 is the ligand. In coordination number 4, 4 ligands in the complexes, 4 ligand in the complex, CN4 are the ligands. 5 coordination number, then the 5 ligand in the complex, 5 ligand in the complex. 6 coordination number, again 6 ligand are attached to central metal atom, again 6 ligands are attached to central atom. 7 coordination number, again these 7 ligand attached to zirconium, that's why 7 coordination number. And 8, these 8 ligand directly linked to the molybdenum, they called as a 8 coordination number. Third terms, coordination sphere. Inner sphere of attraction of a metal is called as a coordination sphere. It indicates as a square bracket. In circle diagram, inner sphere shows this inner sphere called as a coordination sphere, and outer sphere is called as a ionization sphere. These example, all these amines are in the coordination sphere or inner sphere, and all these Cl are the ionization sphere or outer sphere. Next term, effective atomic number, concept related to stability of complexes. This rule is given by English chemist Neville V. Sedgwick. Effective atomic number is defined as the total number of electron in metal or atom or ion, that is atomic number, plus the electron donated or gained from the ligands. The total number of electrons in metal atom or ion, that is atomic number, plus the electron donated from ligands, called as a effective atomic number. That is total association of electron of central metal atom and ligands. This EAN is the atomic number of noble gases, that is stable complexes or stable electronic configuration. Therefore, En decides stability of coordination compound, or if a coordination compound follow En rule, then it is stable one. How to calculate the effective atomic number? Example, An is equal to formula Z minus X plus Y. Z is atomic number of the central atom. X is the number of electron lost during the formation of the metal ion form. It's a coordination compound. And last, Y is the number of electron denoted by the ligand. One ligand is denoted by 2 electron as per the number of actual number of 2 ligand, then the electron is donated by 4. One ligand donated by 2, 2 ligand donated by 4. Example, FeCN6 4 minus, Fe oxidation state 2 plus, and iron Fe atomic number is 26. Fe 26 minus 2, that is oxidation state is oxidation number is the iron is 2 plus number of ligand is 6 into 2. One ligand donate 2 electron, that is, then the calculation is 26 minus 2, that is 24 plus 12 to form 36. That is, this complex is, according to En effect, this complex is more stable and stable noble gas electronic composition, that is krypton. Thank you for watching and listening.